Enter WISE, the Orbiting Wide Field Infrared Survey Explorer. A powerful new tool that just might crack the Nemesis mystery.
The reason that WISE is going to be so good is because it operates in the infrared. It sees heat, basically.
By measuring heat instead of light, infrared scanners can make warm but dark objects easy to spot.
The nice thing about looking in the infrared at the heat of it is you don't care how far away you are from the sun.
Jupiter provides an example. The temperature on the surface of Jupiter measures 230 degrees below 0 Fahrenheit. But that's blazing hot when contrasted with the 450 degree below 0 temperature of space. So even in the absence of sunlight, a distant Jupiter-like planet would glow brightly in the infrared. By visiting a motor speedway, we can see how the WISE survey might help find Nemesis by exploiting the infrared contrast between objects of different temperatures. Here, the roar of the engine only tells half the story.
I came out here today to the Drive Tech Racing School to be in a race car that would go zooming around this track a bunch of times. And the idea was to film the car with an infrared camera and show us things that are hot, hotter than the outside surroundings, and glowing at infrared wavelengths. So hey, Ted.
How you doing?
Good to meet you.
Likewise.
Yeah, you're the driver?
Sure.
Now, how fast are we going to be going?
Approximately 170 miles an hour.
Now, that's about 3 times normal highway driving speed,
Yes,
so
sir.
whoa, things are really going to heat up.
Oh, yeah.
All right, let's go then. Blair Dupree of Drive Tech helped me get into the car.
This is a nice thick helmet.
And it's not so easy because there's no doors, okay? You have to kind of climb in through a window.
Bring your left foot up in there.
Okay.
Your right foot on it. I feel like I'm breaking into a car.
And then kind of slither your way in. Being in that race car was really exciting. When I was going around the turns, I could really feel the G-forces.
Can't give you a good ride. Yeah, well, I'm glad Ted was the driver. I couldn't do this, you know? I was scared out of my seat and I wasn't even the driver, okay?
With the car nicely warmed, a FLIR infrared camera, set up by thermal imaging expert Ross Overstreet, sees everything literally in a new light.
Hello, Allie. Ross, how are you doing?
Doing good. How are you doing?
Good, good. Let's look at these infrared images.
Right now we're pointed at the back of the car. The best way to think about it, this is more of a measurement device than a camera. It's like having a million different thermometers spread across the image. We're actually getting temperature measurements on each of those pixels. Things that are supposed to be hot look like they're glowing, they're red and orange and white. And things that are cold are colored blue and black, and colors you associate with cool objects.
Right.
And you'll notice there's several different hot areas of the vehicle.
Now I see some variations across the tires.
Yeah, and you'll notice that the one tire is a little bit warmer than the other.
The right-hand tire was indeed hotter than the left-hand tire because there was more pressure on it during the turns. So how hot is that hotter tire there?
We made a measurement earlier of about 190 degrees Fahrenheit, almost the temperature of boiling water.
Wow. When we just look by eye, we can't tell whether something is hotter than something else, but here you can tell, and that's really cool.
Right, and this camera would work just as well if it was pitch black or in the middle of the day. It doesn't care about solar light at all.
The infrared camera sees the racetrack the way the WISE survey scans the dark and faraway realms of our solar system. If Nemesis is out there, infrared should reveal it.
The hot spots of the race car are sort of like warm, glowing objects out in the cold depths of space, far from the sun. This is a whole new way of discovering objects. Objects too faint to be seen through a normal optical telescope, but bright enough to be detected in the infrared.
The WISE telescope completed its sky survey in early 2011. But in the search for Nemesis, the results are still inconclusive.
The
The WISE survey is going to take a long time to analyze, simply because there's a huge amount of data that had been gathered by this craft.
About half of the Nemesis candidates have not yet been studied, but in the next few years, we expect the theory will be either proven right or wrong. Until that time, it is and should be controversial.
That something so relatively near to Earth can be so obscure is what Frank Jankowski of Mobile, Alabama, wants to ask the universe. Why can scientists observe objects in space that are millions of light years away, yet have difficulty spotting objects at the edge of our own solar system?
That's an interesting question, Frank. The objects that are millions of light years away that astronomers can see are powerful and luminous. They produce a lot of energy on their own, like an exploding star. But an object near the edge of our solar system might be small, and it reflects only a little bit of sunlight, so we can't see it at visible wavelengths.
But as scientists analyze the data for signs of Nemesis, they have made a disturbing discovery. Although calculations indicate that Nemesis isn't due back for millions of years, something appears to be shaking up the comets in the Oort cloud right now. Could Nemesis already be upon us? Since the birth of the Nemesis hypothesis, astronomers have been on the lookout for a faint red star that periodically disturbs the gravitation of the Oort cloud comets. This sends them on a catastrophic rendezvous with the inner solar system, including Earth, every 26 million years. But as scientists study the Oort cloud, they have uncovered unsettling evidence that something is disturbing comet orbits right now. Has Nemesis already returned?
If the sun was all by itself and there was no Nemesis, then the comets in the Oort cloud would all have very predictable and regular orbits. They would be very regular in their arrival times and departure times.
Without gravitational interference from anything other than the sun, Oort cloud comets, like juggled objects, could spread out evenly across the sky. However, that's not what some scientists report.
When we look out into the sky and look at where the comets are coming from, their directions tend to concentrate in a certain region of the sky. And one possible explanation for that is that that skew is being directed by the gravitational perturbations from an unseen object that is out there.
Based on these observations, scientists infer that a huge object is disturbing the Oort cloud. They do this the same way that California transit officials infer that an accident is disturbing traffic patterns in Los Angeles.
So Marco, where are we? What is this room?
Well, the map we have here on the wall, that's our freeway system map, and as you can see, it shows the major freeway routes in Los Angeles.
The green dots represent normal traffic flow, while the red dots indicate that something is causing traffic to back up.
So the speed here is just one indicator that something's going on, but to really know what's going on, you either have to have a camera or a report from somebody who's actually there and able to tell you what it is.
That's correct.
Astronomers have this problem all the time. They're trying to understand what they can't actually see. In astronomy, we frequently infer the existence of something not because we can actually see it, but because we can see the influence it has on the objects around it.
Whether too many cars are crowding too few lanes during rush hour, or an accident is slowing traffic flow, something causes congestion. Since scientists see similar congestion in the Oort cloud, could Nemesis be the perpetrator?
This place is very impressive. It's got all the cameras, all the sensor data, all the California Highway Patrol incident reports. This is far more data than astronomers have to work with. If we only had remote cameras all throughout the outskirts of the solar system, we might know a lot more about it.
Even without remote cameras, scientists have proposed a remarkable theory to explain the congestion in the Oort cloud. According to this theory, the culprit disturbing the Oort cloud isn't Nemesis. Instead, it's something equally astounding. A giant, undiscovered planet 4 times the mass of Jupiter. In short, the largest planet in the solar system. Scientists have proposed naming it Tyche.
In a nutshell, Tyche is Nemesis light. Nemesis, in the original hypothesis, was literally a red dwarf star, something that was 100 times more massive than Jupiter.
Unlike Nemesis, Tyche would not glow like a star. Instead, it would look like a strange version of Jupiter.
If you put on night vision goggles, then it would be quite a bit more impressive sight. You would see breaks in the clouds, and there would be lightning. You would see the clouds light up from the lightning down beneath the cloud tops.
Tyche may disturb the orbits of comets in the Oort cloud, but it can't be the source of Earth's periodic extinctions. First, its proposed position puts it on a 1 million-year orbit, not 26 million like Nemesis. Second, it's too small.
Tyche doesn't really have the gravitational mojo to dislodge comets, send them crashing in these periodic extinctions, really rearrange the Oort cloud. And so its effects would be visible only in these small skews and not in the form of huge pulses of comets coming out of seemingly nowhere.
Just as with Nemesis, NASA's WISE survey should be able to detect Tyche if it exists. While it's surprising that our solar system might harbor a giant undiscovered planet, it doesn't support or refute the idea that it also harbors the undiscovered star, Nemesis. But a recent finding in the outer solar system may shed more light on whether Nemesis really exists and the kind of threat it may pose to life on Earth. In 2003, astronomer Mike Brown made an historic discovery when he found something floating around the night sky he couldn't explain.
I remember the day that I discovered Sedna, looking at it on my computer screen, looking at these pictures. My first reaction was, that can't be real. It's too far away. Nothing like that exists in the solar system.
What he stumbled upon turned out to be a planetoid just smaller than our moon, now named Sedna. But Sedna presents a scientific quandary. At its nearest point, Sedna lies about 3 times farther away from the Sun than Pluto, in a region where astronomers never expected to find planetary bodies.
It's the coldest, most distant place that we know in the whole solar system. If you're sitting on the surface of Sedna, you could take a straight pin and hold it out at arm's length, and with the head of that pin, you could cover up the Sun.
In addition to being in an unexpectedly distant region, Sedna also takes a wildly elliptical orbit through the solar system. The mystery is, there's nothing anywhere near Sedna that could account for an orbit that distant and that extreme.
The place where it is now, nothing ever affects it. It doesn't come close to any planets. There are no stars that ever come close to it.
So what forced Sedna into its unique orbit? And in theory, could the Death Star Nemesis have played a role? For Brown, the bounce of a trampoline offers a way to understand how Sedna ended up in an orbit that remains a head-scratcher for astronomers.
I have behind me a measuring stick that gives how high I'm going to bounce in 2-foot intervals you see here. And what that bounce is supposed to represent is how far away from the sun I am in my orbit. In a normal planetary orbit, in a circular planetary orbit, the planet circles around the sun, always staying the same distance from the sun. And that's sort of like me staying on a trampoline, always the same distance from the floor. Other sorts of orbits can be, instead of going in a circular orbit, you can go in an elliptical orbit around the sun. You move away from the sun, you come back towards the sun, and so you'll be moving further away, getting closer, and that would be starting to jump up and down on the trampoline.
Like gravity keeping us in orbit, when we reach the apex on the trampoline, gravity will pull us back down.
So as long as nothing happens to me, I stay in this orbit forever, jumping up and down, always to the same height.
But something unusual afflicted Sedna. It brushed up against a mysterious force that shoved it into a region where no planetary body should exist. Some suspect that force was Nemesis. And if the sun's evil twin is out there, scientists can tell exactly when we'll see the terrifying signs of its return. As astronomers search for a Death Star named Nemesis that might periodically cause mass extinctions on Earth, the recent discovery of a tiny world named Sedna could prove key. Billions of years ago, Sedna revolved around our sun like other planets in a nearly circular orbit. But then, two strange things happened. First, something forced Sedna into an extremely elliptical orbit. And then something else pushed that orbit out so far that it seems to defy any visible explanation. The first question, what caused its elliptical orbit, is fairly easily explained. It could simply have been gravitational tugs from the outer gas giants Jupiter and Saturn. A trampoline can help illustrate.
To really understand how orbits in the solar system work and we get these very elliptical orbits, we need to get more height on the trampoline, and I can't do it. So Ken, I'm gonna need your help.
Oh, awesome, I'm ready to help.
Let me get out of your way.
Just as extra people on a trampoline create extra bounce, the large gas giants in the solar system can create enough gravitational bounce to stretch a smaller body's orbit into a wide ellipse.
So here's Sedna on a nice elliptical orbit, but then Sedna got a little bit close to one of the planets. As soon as it does that, the extra gravity of the planet gives it a little boost into an even more elliptical orbit, but then it gets close to another planet. Let's say Jupiter. Here comes Jupiter. It bounces even higher. With enough bouncing from Jupiter, we could bounce Sedna all the way out of the solar system.
The orbital bounce provided by Jupiter and Saturn can explain how Sedna's orbit got its elliptical shape, but not how it ended up being forced into a distant region of the solar system, where scientists never expected to find a planetary body.
Sedna was on an elliptical orbit, getting further and further and further, and then something happened to it when it was out here. Some other gravitational force pushed it off into a different orbit, and so it didn't come back to the same place it was before.
It's as if some second gravitational force was passing by and shoved Sedna onto a different trampoline so that it bounces in an unexpected region.
The most likely answer is that there was another star very, very close to the sun at the time when Sedna was going through this process.
The solar system probably formed in a cluster of stars, and so close encounters with nearby stars, nearby rogue planets even, were much more common during the very earliest days of the solar system's formation.
Most of these solar brothers and sisters have long since dispersed. But according to the Nemesis hypothesis, one of them is still out there, still circling the sun, still causing periodic chaos amongst the comets, and still waiting to rain death on the Earth once more. If that is correct, future generations will be faced with a monumental threat when Nemesis returns. In 10 million years.
The moon, Mars, planets would basically be unaltered from their current condition. On Earth, the cities might not be there, but the continents would still be almost in exactly the same places that they are now.
But according to the Nemesis hypothesis, a major change is underway 1 light year from the sun. A dark reddish star has entered the Oort cloud. Nemesis has returned. If humans still exist on Earth, they'll face a slow building but imminent cosmic threat.
The Oort cloud contains perhaps 10 trillion comets, maybe even more. But remember, it's really big, so if you were in the Oort cloud, it's not like you would be pelted by comets all the time. The spaces between them would be pretty big.
Like a bowling ball in a juggler's hands, Nemesis simply shuffles some comets out of its way.
The Oort cloud has an empty region in the middle. It's been cleaned out by Jupiter and by the sun. We live in that region.
But as Nemesis approaches, the inner solar system becomes a shooting gallery.
And so there start to be a few more comets than usual, and then suddenly there are just comets coming all the time.
And at the peak, there might be 1,000 to 10,000 comets per year in the sky.
According to the projections, Earth would be in the crosshairs of this comet storm for 1 million years.
Over a period of 1 million years, there would be visits by about 1 billion comets. Well, actually, you do the calculation, it turns out one of them will hit the Earth, 1 or 2.
It would be difficult to predict exactly when the impact would happen, but there would be this phase, this sort of danger zone in which the chances for a catastrophic impact with something of comet size would be much, much higher than they are now.
Will the impact spark another catastrophic extinction on Earth? Perhaps, but only if we let it happen.
I like to joke that Nemesis planned this one poorly. In between the last extinction and the next one, there's plenty of time for intelligent life to get its act together to make sure that next time Nemesis comes back and the sky is filled with comets, to make sure that none of them hit us.
Is this future inevitable? Until scientists either discover Nemesis or definitively rule it out, no one can know for sure.
It's important to realize this is not just an abstract discussion. Clearly, these objects colliding with Earth happen very rarely. But on the other hand, when they do collide, they're extremely cataclysmic. So what we need to be able to do is get better understanding of our solar system.